Statistics is the science of learning from data. 8 words, that's the whole definition. And then everything else this semester is really just those 8 words getting more specific. The longer version goes like this. Statistics is the science of collecting, organizing, summarizing, and analyzing information in order to draw conclusions or answer questions. And this next part gets forgotten constantly. It also gives us a measure of confidence in those conclusions. Before we touch any of it, look at what data actually is, a pile of numbers. That's all it is sitting in a spreadsheet and not doing anything for anybody. Numbers on their own don't tell you a single thing, not one thing. Turning that pile into something a person can use is basically the whole job. 4 moves. Collect, you go out and gather the data. Organize, you put it in some kind of order because a heap is not an order. Summarize it, graphs and numbers, so a human being can actually see what's in there and analyze it. You find the pattern. Then only then you draw a conclusion. Here's the step people skip. Once you've drawn the conclusion, you say how confident you are in it. Statistics almost never says definitely. It says probably, and here's how probably. That careful wording isn't weakness. I'd argue it's the most honest part of the whole subject. You already do this, by the way. Every December, your music app hands you your top 5 songs of the year. That's 12 months of listening data, summarized while you weren't paying attention. Your weather app says 70% chance of rain today, and that number is a probability built out of thousands of past days that look like this one. A sportscaster says he makes 42% of his 3-point shots, one number standing in for an entire season. A medicine label says that this drug helped 9 out of 10 patients, a conclusion pulled out of a small test group and pointed at everybody else. 4 ideas from this course, and nobody called any of it statistics. Statistics splits into 2 branches, and almost every question you'll be asked this term is secretly asking which branch you're standing in. Descriptive statistics is organizing and summarizing the data we already have. That one word is doing all the work. You measured it, you counted it, it belongs to you, and you're just describing what's sitting in front of you. He made 42% of his 3-point shots. That's descriptive. He took those shots. Nobody is guessing about anything. 2 ways to summarize pictures, a pie chart, a histogram, a bar chart. Anybody can read a picture, even somebody who's never taken a statistics class. You flip open a magazine, you see a chart, you get it in about a second. Or numbers and the mean, the standard deviation. One number that speaks for 1,000, which is where the software comes in. In lab, we use the R. It's free, it's open source, you could download it tonight, and then it exists because nobody on this earth is building a histogram out of 1,000 data points by hand. You hand R the raw file, you type 1 line, and the chart is just there. That's it, that's the trick, and we spend real time on it in the lab sessions. The other branch is inferential statistics. This one uses a sample to say something about a population we did not measure, did not. We never asked those people, never tested those patients, and we're going to make a claim about them anyway, which sounds a little reckless, right up until you add the second half. The second half is a probability. Inferential statistics uses a probability to tell us how confident we can be that our conclusion is correct. 9 out of 10 patients, that's 10 people, and the claim is about everyone. So we attach a number to our own certainty. 90% sure, 95, that number is not a declaration. Most of the time, it's the actual answer. Population, individual, sample, 3 words, mix them up and nothing downstream works. The population is the entire group to be studied, all of it, every last one. Suppose we care about the students at UD, all 1,500 of them, that's your population. And notice it depends completely on what you're curious about. Ask about the college students in the whole Dallas area, and then your population gets huge. Ask about one campus, and it shrinks right back down. Any one of those dots is an individual. one person, one object, one thing that belongs to the group, one student. That's the smallest piece you got. And the sample is a smaller part of the population that we actually study, 60 students out of the 1,500. That's the whole idea. You go ask 60 people. Then inferential statistics takes the result from that sample, stretches it back across the entire population, and measures how reliable the stretch is. So why not just ask everybody? 3 reasons. Faster, one afternoon instead of many weeks, cheaper, less time, fewer people, less money, and sometimes it's flatly the only way there is. A doctor cannot test a new medicine on every person on earth, obviously, so you test some and you reason your way out to the rest. But, and this is the part that quietly ruins studies, a sample is only useful if it looks like the population. Here's the one I always tell. Say your city has an empty lot and can't decide, another park or a library. Somebody goes out to survey people, and they run the whole survey at the dog park. What are the people at the dog park going to say? Park, every one of them, more or less. You can't bring the dog into a library, so the survey comes back overwhelming and it's wrong. Not because anyone counted badly, but because they only ever asked one corner of the city. A bad sample gives a wrong answer no matter how big it is. 10,000 people at the dog park is still 10,000 people at the dog park. Both of those groups can hand you a number. The 2 numbers have different names, and the exam will absolutely check whether you know which is which. A parameter is a numerical summary of the population, and the catch is that we usually don't know its true value. It's out there, it's real, it just isn't something we can go and get. A statistic is a numerical summary calculated from the sample data. That one we can always compute because we're the ones who collected it. The memory trick is almost too easy. P and P, population, parameter, S and S, sample, statistic. The letters match. That's it. That's the whole thing. And I have watched it save people on a test. Suppose the true average GPA of all 1,500 UD students is 3.21. That describes everybody, so it's a parameter. Now you survey 60 students and their average comes out to 3.34. Same quantity, different group, so that one is a statistic, close, not the same. They're basically never the same, which means that every measure you meet has 2 symbols, one for the population, one for the sample. Size is a capital N for the population, lowercase n for the sample. The mean is mu and x bar. Variance is sigma squared and s squared. Standard deviation is sigma, and so the correlation coefficient is rho, and the proportion is p and p hat. There's a pattern underneath all of that, and I find it genuinely lovely. Greek letters describe the population. Roman letters describe the sample. So when it's week 9 and you've forgotten everything, look at the alphabet. It'll tell you which group you're standing in. Quick one, 2 students out of all 29 students in the class have red hair. Is that a parameter or a statistic? Careful here, it's a parameter, and the reason is the group, not the number. All 29 students in that class is the entire group being studied. Nobody sampled anything. There's no bigger class hiding behind it. So the group is a population, and the number describing a population is a parameter. The trap is the word 2. 2 feels small, and small feels like a sample. Ignore how big the number is. Look at who it describes. Now let's put all of it together on one real survey. A news service surveyed 1,055 adults, age 18 and older, in a certain country from August 31st to September 2nd, 2022. They asked, of every tax dollar the federal government receives, how many cents are wasted? Of the people surveyed, 36% answered 51 cents or more. Then the news service reported that 36% of all adults 18 and older in that country believe the government wastes at least 51 cents of every dollar. Margin of error 5%, confidence level 90%. First question, what's the population? not the 1 out of 55 people. That's who they managed to ask. The population is everybody they want to describe. Adults in the country, age 18 or older, ask yourself who the conclusion is about, and there it is. Then the sample is the 1 out of 55 adults who were surveyed, who they actually reached. And notice those two questions are nearly the same sentence. Who do they want to describe versus who did they get on the phone? That's the whole difference. Third, which statement is descriptive statistics? This one, 36% of the individuals surveyed indicated 51 cents or more is wasted. Surveyed, it only talks about the people in the room. Nothing has been claimed about strangers. That is a description of data we already have. And what can we infer? The news service is 90% confident that the true percentage for all adults in that country sits between 31% and 41%. Where does that band come from? 36, give or take, the 5% margin of error, not a 36% exactly, a range, plus an honest note about how sure we are. Inference always hands you both. One more piece of vocabulary before we start reading tables. A variable is just a characteristic you're interested in, the thing you decided was worth writing down. We label them with capital letters, X, Y, Z, same as algebra, honestly. You've been doing this since you were 14. And the data are the actual values the variable takes. Suppose X is the weight of a student, then X is the variable, the idea, the characteristic, and 96 pounds, so 1 to 21, 105, 111. Those are the data. The variable is the question. The data are the answers. And they don't have to be numbers. Words count as data too. Every data set you'll ever open is a table. And a table asks you 5 questions. The 5 W's, 2 of them live in the shape of the table itself. Each row is one who, one case, a person, an animal, an order, a session. And each column is one, what, one variable that somebody recorded. Rows are the who, columns are the what. If you remember one thing out of this whole chapter, make it that. Then where, the place the data came from, when, the time or date it was collected, and why, the reason the study was done at all. That last one matters most. The why is what decides whether any of the numbers mean anything. Same table, different why, completely different conclusion. So, researchers studied the effect of tutoring on test scores. They collected data from 825 tutoring sessions during 2020 to 2022. For each session, they recorded the student's age, how many weeks the tutoring lasted, the type of tutoring, structured, unstructured, or combined, how often the student was tutored, the student's GPA, the student's sex, and whether the student improved. Who is this data about? Not the 8 to 25 students, the 8 to 25 tutoring sessions. So read the sentence again. For each session, they recorded. Each row is a session. One student could show up in 5 different rows. The case is the session, and the people slide straight past that. The what is every column. Frequency of tutoring, sex of the students, GPA of the students, type of tutoring, the student's improvement, the student's age, and the duration of the tutoring. 7 variables. 3 of the choices are traps. Number of tutoring sessions is not a variable. That's just how many rows there are. Average improvement is not a variable. That's a summary you'd calculate afterward. And the duration of the study is the calendar span, 2020 to 2022. That's a when, not a what. Where did this happen? It doesn't say. And the correct answer is exactly that. The information is not given. It is completely normal for one of the 5 W's to be missing. When it's missing, say so. Don't guess. And I do mean that writing at a tutoring center, because it sounds plausible, is worse than writing nothing at all. And why? to determine the effect of tutoring on the students' test scores. Test scores, not GPA, even though GPA is sitting right there in the data. GPA is a column they picked up along the way. The why is what they set out to find in the first place. Last big idea, and it's the one you'll use every single week. Before you analyze any variable, you classify it, because the type decides what math is even allowed. Two families, categorical and quantitative. Qualitative data is also called categorical, tells you which group each individual belongs to. You don't average it, you count it, and it shows up in 3 flavors. Nominal name's a category, and there's no order to it. Male, female, country of residence, eye color, zip code, which surprises people every year, but a bigger zip code isn't more of anything. It's a label made of digits. Nothing sits above or below anything else. Ordinal has an order, but no real units. Strong buy, hold, sell, small, medium, large, A, B, and C grades. You can line these up. Large really is more than small, but the gaps between the levels aren't equal and they aren't numbers. The step from small to medium is not a measurable amount of anything. And an identifier is a unique value for every single case. Your student ID, an order number, a passport number. It's perfect for finding one record and useless for analysis. The average student ID number is a thing you can absolutely calculate. It means nothing whatsoever. Quantitative data are measured numbers with units, where doing math actually means something. 2 kinds, discrete. You count it, and the possible values have gaps in between. Number of touchdowns, number of siblings. Nobody has 2.5 siblings. Continuous. You measure it, and it can take any value in an interval. The weight of a diamond in carats. The delivery time, height. When you're stuck, 2 questions. If the answer to how many is always a whole number, discrete. If a better instrument would give you more decimal places, continuous. That second test is the sharper one, I think. Buy a better scale, get more digits. That's continuous. Let's classify something real. 1 food delivery order, 6 variables got recorded, order number 482123, restaurant type, pizza, star rating 4 out of 5, number of items 3, delivery time 27.4 minutes, and the distance to the restaurant 3.7 miles. Order number is an identifier, unique to that order, no math allowed. Restaurant type is categorical, nominal. Pizza is more or less than sushi. Star rating is categorical, ordinal, 4 beats 3. But the step from 3 to 4 isn't a measured quantity. Number of items is quantitative, discrete. You counted 3 things. Delivery time is quantitative, continuous. A better clock gives you 27.42. And the distance to the restaurant is quantitative, continuous. And there's that sharper test doing exactly what it promised. A better instrument doesn't hand you 3.7 miles. It hands you 3.68, then 3.684. Those decimals were there the whole time. You just needed something good enough to read them. 6 columns. 5 different answers, 1 line out of some app's database, and you've used almost every category in this chapter. That's not a coincidence. That's what real data looks like. 5 things to carry out of here. 1, statistics is learning from data. Collect, organize, summarize, analyze, and then you say how confident you are. 2, descriptive describes the data we have. Inferential uses a sample to talk about a population. 3, population and parameter go together. Sample and statistic go together. 4, in a data table, rows are the who and columns are the what. 5, classify every variable before you analyze it. Categorical meaning nominal, ordinal, or identifier, or quantitative meaning discrete or continuous. The handout has more in it and we worked through here. The zip code questions, the diamond, the quarterback, a whole page of extra practice. Do those. Not because I'm checking, but because classifying variables only gets fast through repetition, and you want it fast before the math shows up. The reading is part 1, chapter 1. Once that's done, you're ready for lab quizzes 1.1 through 1.3, and the lecture quizzes 1.1 and 1.2. And the next time we start the real inferential work, hypothesis testing, how you decide from one sample whether to believe a claim about a whole population, and how you keep it from fooling yourself while you're doing it. Bring this vocabulary with you. You'll need every word of it.